Tonight's homework video for 3:10:15 is really important because I'm not teaching you something that I've already taught you in class and just practicing. I'm actually going to teach you something new tonight. And the good news is it's not brand new to you. You've done some work with it, but there's a lot that you haven't done with it that we haven't added yet. So it's really important that you listen. You're going to need to take notes. I'll tell you exactly what you need to write down. And don't forget that you can pause things and re-listen. It's important that you understand tonight so that you can get this. Many of you asked me questions about these kinds of problems on your interim math assessment when we did it last week. And so I've decided to give you a little bit of experience with these kinds of problems on your homework for a couple nights. So the first thing is, this idea is really taking something you've already done and just making it a little tiny bit harder. So the thing you've already done is you looked at equations like this when there's variables on both sides. And I want you to go ahead and copy this problem down. 3x minus 2 equals 2x plus 4. And I'm going to wait for you to do that for a second here. And then make sure that your paper says 3:10:15, because these notes are really important. I want them to be written neatly, and they're important because we haven't done this in class, so it's important you do a good job tonight. Now, to solve a problem like this, we have to get the x's on one side. We can't have them on both the left side and the right side. So we can subtract 2x from here and 2x from here. When we do 2x from here, we don't have any x's left over here. When we do 2x from over here, we still have 1x left. So then, now we have x minus 2 equals 4. And so to get the x by itself, to solve for x, we add 2 here and we add 2 here. That gives me x equals 6. And so that problem is solved. And again, you've done problems like that. The only thing I expect you to have so far is this problem with its work. You don't need to write this. And the date on your paper. Nice and neat. So now for the new idea. This needs to be written down. You don't need to label it new idea, although you may if you want. All of this needs to be written down. When an equation has x's on both sides, it is really two equations being set equal. In math, we call this a system of equations. And remember, you can pause if I didn't give you enough time to write that. So the big important new vocab is system of equations. In other words, this guy right here is a system of equations because you have the equation 2x plus 4 being set equal to the equation 3x minus 2. System of equations. And all of this also needs to be written down. And again, remember, you can pause the video if I'm going too fast. Systems of equations will always have three possible ways the answer can occur. You can have one answer, one xy ordered pair answer. You can have infinite answers, and you can have no answers. Okay, now I'm going to go back to my first screen, and I just want to show you this is a system of equations, two equations that are set equal, and it has one answer, one ordered pair, but I haven't solved this problem all the way out. What I've done right now is I found the x. In order to solve it all the way, I would also have to solve for the y. And I'm going to show you how to do that tomorrow. Today I just need you to know that this isn't the complete answer. I would really need the x and the y. And again, I'll show you how to do that tomorrow. Okay, so you can get one answer, an xy. We got part of that on our first problem. You can get infinite answers, and sometimes when you solve systems, you get no answer at all. Okay, now I need you to make your paper into a chart, and I don't know how big it needs to be, but it needs to fit everything that I have on my chart on yours. If you need an additional piece of paper, use that. Remember, you can always go back and pause. You can re-listen to make sure you understand this now. When there's one answer, one xy, you'll see two equations set equal like this. And if you were to put them on your graphing calculator, this is y1 and this is y2, you'd see there's one place on the coordinate plane, one xy, where they intersect. One point where they intersect. Make sure you have this written down. Now there's something special about this equation and this equation and the way that they're written that causes them to have just one place where they intersect when you graph them, meaning just one xy answer when you solve them algebraically like I did problem number 1. And we'll talk about that on the next screen. It's also possible that you'll have infinite answers. So here's an equation set equal to another equation. You should notice something kind of silly here. And when you graph this system of equations, what you're going to get on your screen is two lines on top of each other. And of course you can't tell that. It looks just like one line because you can't see the other line underneath this line. But it is there. Okay? So if there's infinite answers, that means that the two lines are really on top of each other. And of course that can only happen if the two equations are exactly equal. They're the exact same equation. So of course when you graph it, they lay on top of each other. The third possibility is you have no solutions at all. So for instance, oops, and I have a little extra thing in here. Let me erase that. If I gave you x minus 3 equal x plus 2, and you graphed that, this is x plus 2 and this is x minus 3, you've got two parallel lines which will never touch, never intersect. Because of that, there are no solutions, none. Two parallel lines that will never intersect. Make sure you have all three of those copied, and I do want you to copy the sketches. Don't worry about the sketches being perfect. Just worry about over here, show one intersection point. You know, it doesn't matter what two lines you graph, so here two lines are on top of each other so you can only see one line, and here you have two parallel lines. Be sure to pause and go back and re-listen if there's something you didn't understand there. Okay, I said that I would show you what's special about the equations that causes them to have one solution, and so I want you to make sure you're writing this part down too. Look at this equation, 2x plus 6 equals 5x plus 6. Notice that the y-intercepts are the same. They're really not important. I could make these anything, 7 and 2, 5 and 4. It's the slopes that are important here when there's just one solution. And what's important is that the slopes not be the same. They're different. So here my slope is 2x, here my slope is 5x. Because they're different, these two lines intersect in one spot on the graph. Just like here, my slope is 3x, my slope is 1x. Because my slopes are different, the lines only intersect in one place. For infinite solutions, and I wrote this one different than the one I wrote over there, I made it a little bit harder. Here I have a slope of 3, and here, if I multiply 3 times this invisible 1 that's in front of the x, 3 times 1 is 3. So both slopes are 3. Okay, they're not different. They were different over here. And the y-intercept here is 12. And if you do 3 times 4, that's why I connected these, 3 times 4, the y-intercept on this one is 12 also. That means these are the exact same equation. Just like over here, they were exactly the same equation. And whenever you have two equations that are exactly the same, set equal to each other, you're going to get infinite solutions because the lines lie on top of each other. And often you won't be able to tell that they're exactly equal to each other until you do some math, just like I had to multiply 3 times 1 and then 3 times 4 to see that I had the same y-intercept and the same slope. What about none? What about having no solutions? Well, here I have 2x plus 3 set equal to 2x minus 9. In this system of equations, again, my slopes are exactly the same, my m, my constant rate of change, but the y-intercepts are not the same. This is 3, this is negative 9. So in this case, for no solutions, the slopes are the same. That causes the lines to be parallel, and the y-intercepts are different. That causes them to start at different places on the graph, and because of that, the lines will never touch. They have the same slope, but they start in different places, so they'll never touch. So the big idea tonight is to understand that when you have two equations, it's really a system of equations. You can set that system of equations equal to each other and solve, and when you do, there will either be one answer, infinite answers, or no answers at all. One answer comes from having two different slopes. Infinite answers comes from having two identical equations. Sometimes these are called identities, by the way. And sometimes, if you have no answers, that's when the slopes are the same, but the y-intercepts are different because the lines are parallel. That's all for homework tonight. If there was something you didn't understand, you're going to be using this tomorrow, so rewatch part of the video or rewatch the whole thing. It's only 13 minutes. Have a great night, you guys.